All right, so we're going to start off looking at section 4.1. Okay, as Mr. Roy said earlier, all the problems this week are word problems. All right, but we've tried to come up with a system that's going to make it consistent and somewhat easier for you guys to do them. Okay, so what we're going to do in section 4.1, okay, we're basically going to be given a sentence. Okay? And we're going to have to translate that sentence into math. Okay, we've seen some of the words before that you need to use, like is. Anybody remember? Yeah, is, of, those are important words. Okay, we're going to see some of these words, increased by, decreased by, and we'll talk about what they mean again in case you forgot. So in general, we're going to have a relationship between two, or it could be three things. Okay, we'll look at a couple of types today. So, no, I'm just explaining what we're doing. Okay, so our goal is we're going to be writing two algebraic expressions. And if you look on a sheet we're going to give you in a little bit, it's going to have two lines on it for you. So you're going to have to come up with two different algebraic expressions. All right?
So guys, where it says goal, with the little colon next to it, you got to write what Mr. Hager underlined, right? Write two algebraic expressions, one for each quantity described in the problem.
Okay, so that's the goal. Okay, I think once I show you an example, then it's going to start to make sense. Okay, here's an example of a typical kind of problem that you see from this section. Jack's age is 1 year less than twice Paul's age. Okay, so Jack's age is 1 year less than twice Paul's age.
On your notes. And then what the directions will say, guys, on a test, on the homework tonight, it'll say exactly this. Choose a variable to represent one unknown, then represent the other unknown in terms of that variable. So on the homework we have tonight, the majority of it is going to have those directions. So we're going to give you guys the steps right now to set up those kind of things.
So when we represent, one of the unknowns, one of the things you represent is always going to have just a single letter. The other one is going to be a little bit more complicated, but one of them is always going to be a single letter by itself. Nothing added to it, nothing subtracted from it, nothing multiplied by it, nothing divided by it. Just a letter. And then we'll talk about the second one in a minute. Okay, so step one you want to write in on your sheet is first we have to identify what are the things in the problem. Okay? In this case, it's two people. Jack's age, Paul's age. Okay? Those are the two things we have to find.
Again, guys, most times it says if necessary up there. Most times you're only going to have to find two, but there are some stuff we're going to get into later in the week on Thursday where you're going to have to, and we have one problem today where you're going to have to solve for three things, and later in the week you might have to solve for three things. But most of them, guys, are only going to be two. We might give you one, like today, one challenge problem where you have to solve for three, but most times it's going to be two. That's why it says in parentheses there, if necessary.
Everyone see that in this problem there's only two. Jack's age, Paul's age. Those are the only two things. Okay, so the first thing is identify what are the two unknowns.
So guys, under your step one, you're going to want to write your unknown number one is Jack's age. Unknown number two, Paul's age. Those are the two things that you have to find, or that you're setting up for.
Okay, so next step, step 2A.
So guys, make sure you get down what unknown one is and what unknown two is. Make sure you put unknown one as Jack's age and unknown two as Paul's age.
Okay, step 2A, you got to represent one of the unknowns as a single letter. And I'm going to give you a hint to help you figure out which one, either Jack or Paul, is going to get the single letter. what you want to do is look at the one at the end of the sentence. Okay? Whichever one appears at the end of the sentence, that's the one that gets represented by a single letter.
So guys, you might want to add to step 2A, usually, maybe put usually the second thing in the problem. Or at the end. There you go. Or at the end of the sentence. Yep, you might want to add that to your step 2A.
Okay, so if we look at how it was written, Paul's age was the one at the end of the sentence. So what we're going to do is we're going to represent Paul's age by a single variable. Right? Sometimes you pick a letter that has to do, like you might pick P for Paul. You can use X. You can use whatever you want. But the idea is it's just going to be a single letter. So this is how you want to represent Paul's age, X.
We're going to be taking out two unknowns, right? And Paul's age would be the X. Because why? Why is it going to be the X, guys? Huh? It's the second thing in the sentence, right? 99% of the time, the second thing in the sentence is always the unknown. Again, you can do it as X, you can do it as P, you can do it as A, whatever you want. Doesn't matter. I usually do it as X. I do it that way for all problems. Until we get to the stuff later in the week, we might have you represent the variable with an N. But again, for word problems, you can use X, you can use whatever letter you want. Doesn't matter.
So we've got Paul's age represented as X. So next thing we have to represent is Jack's age. Okay? We have to represent Jack's age. Okay, so now we're going to represent the other unknown, but we have to go back and read what the sentence said based on the information given.
So this is when it gets a little bit tricky. This is when you might have to, you're gonna have to know what certain things mean. Decreased, increased, times, things like that. You need to know how to translate those words, those English words to math terms.
And when we do step 2B, and I think we say this again later on, you want to make sure you use the same letter. You're never using more than one letter, ever. Okay, for every problem we do this week, it's one letter.
Use that same letter in both things. Don't use X for Paul, don't use a P for Paul's age and a J for Jack's age. All right, when you set up for the variable, it has to be the same.
Okay, now we got to figure out how do we represent Jack's age. Okay, let's go back and look at what our sentence said. Jack's age is 1 year less than twice Paul's age. Okay, start with Paul's age. What was Paul's age again? How did we represent it?
X.
X. Okay. Now let's read it through. Jack's age is 1 year less than twice Paul's age. Start with that. What would twice Paul's age be?
2x.
2x. And now what would 1 year less than that be?
Minus 1.
Minus 1. So 2x minus 1 is Jack's age. So now we've got Paul's age is x, Jack's age is 2x minus 1.
Can you go back up to that, to the problem there? Again, guys, some people, let's put on 1 second, Mr. Hager. Some people fall into this habit. 1 minus 2x.
It's not the same thing.
All right, you don't want to do it that way. When it says less than, or decrease by, or anything when you have to use subtraction, always put that as the second part of whatever you're representing. All right. In this case, we're doing Jack's age, right? Do that as the second piece. Do the minus part as the second part, and then put your whatever you're representing at the beginning. Always do the decrease by, or subtracted by, or whatever. When you're using subtraction, it's always the second part. Don't put it at the beginning.
If you get stuck, think of it as, what if I said to you, 1 less than 5? Think of what's 1 less than 5?
4.
Right. To do that, you did 5 take away 1, and you got 4. Okay? So you have to think of it in that order. Okay? Now, for this problem, that's pretty much it. We're not actually going to find Paul's age. That's going to be tomorrow. We're not actually going to find Jack's age. That will also be tomorrow. All we're doing today is setting up the two expressions, x and 2x minus 1, that would help us to find their ages. In fact, this problem doesn't even have enough information if I wanted to find their ages. I need something else here. So that's all you can do. And that's all we're doing today. Okay, any questions on how we did that? Paul's age is x. Jack's age is 2x minus 1. All right, and it gets easier once we practice. What's that? That's going to be the answer, x and 2x minus 1. Tomorrow, we'll actually find out how old Jack is, how old Paul is. Not today, though. We're going to stop there, and that's all you got to do. So next, we're going to go over some key terms that if you see, you need to know. Do they mean add? Do they mean subtract, multiply, or divide? Okay, what are some terms that we usually see that mean addition? Yep. Positive?
Plus sign, yeah.
Plus, yeah. If you see plus, that means addition. Sure, what else means addition? Yep. More than. Exactly. If we had 2 more than x, means x plus 2. Okay. Add. Yep. Increased by. Okay. Some. More than. All those different words mean
So guys,
addition.
on your sheet, put your headings, right? You have a table that looks like that. If you on that page I just handed to you guys. I just walked around, Mr. Hager was finishing up, I just handed it to you. You want to put operation, and at the top you want to put operation and word.
Those are already there.
Huh?
Those are already there.
Oh, something's already there? Okay. All right, good. And then it's fill in, addition, subtraction, and then obviously in parentheses, like I told you guys earlier, you want that to be the second part of your problem. Minus 1, decrease by 1, decrease by 2. It's always the second part. X minus 1, it's always the second part. So your operations are going to be addition, subtraction, and make sure put in parentheses needs to be the second part, multiplication, and equals.
Okay, now for subtraction, there's many different ways you could see that written. Okay, you could see it written as decreased by. Okay, that's one way. You could see it as difference. Okay, so subtraction is one. You have to be careful of the order. Okay, for example, if I said the difference of x and 3, the difference of x and 3 means to do that. Right? So if you see the word difference, you pretty much keep it in the same order. If you see decreased by, which I think is what we have, no, not there. Okay, but if you see this example, Bill worked 2 hours less than Jeannie. It's x minus 2, not the other way. Again, think if I said to you, what's 2 less than 10? If you wanted to figure out what 2 less than 10 is, you'd do it that way. You wouldn't do 2 minus 10. That wouldn't make sense. 2 less than 10 is 8.
So guys, some of the words for subtraction, what are some words that like, I guess, code for subtraction that we've come across so far? Who could tell me? Give me one. Savant?
Less than?
Yeah, some up there, right? Less than, difference, fewer than, or decreased. All right, so those are 4 of the most common ones that are going to show up in the problems that we do. All right, so less than, difference, fewer than, or decreased. So you want to have subtraction on there, and you want to have those words in the bigger column.
Okay, multiplication, some of the words you might see is like twice. I think we just did that. Twice Jack's age. That means you multiply by 2. If you saw 1/3 of, okay, something like that, that also means multiply. 4 times Sarah's age, that would mean multiply. If you see product, the product of 2 numbers, that would mean you're going to multiply. There's a lot of different ways you can write multiplication.
All right, so guys, up there it says, if you can't see it that well, it says twice equals 2x, right? 1/3 equals 1/3x. 4 times equals the number 4x, right? And then Mr. Hager just added product. All right, you want to look, again, those are the most common ones that we're going to see when we do these problems.
And then words for equals, what's the most common word we see for equals? Is.
Yeah.
So is. A few other words depending on the type of problem
Yeah,
that
but
might come up.
if you're dealing with money, guys, you might get total, all right, cost. Sometimes you have, they use have also. So for equals, we have is, total, cost, and have. And those are the 4 most commons that we'll see.
And if we come across one that we didn't see, we'll explain it as we go, or we'll just try to reason through it together. Okay, any questions on those keywords there?
Again, guys, these, like, even tonight, tomorrow night, even on Thursday night, use this. Use this little table, guys. I don't even care if you wanna cut it out of your notes, so it's a little bit easier to get at. But that's what you're gonna need to kind of figure out what those keywords mean. Is it subtraction, multiplication, whatever, okay? Guys, up on the board, this is like tomorrow, this is like the first step. Well, it's actually the first and second step that we talked about earlier. But this is the template that we're gonna use. So tonight on your homework, you're gonna have a bunch of these, it's gonna be set up, we were doing, you know, a certain page and certain numbers tonight, right? You'll be given a sheet tonight for homework with a bunch of these on it. All right, so the template will be on there. Tomorrow when we get into, when we have to solve word problems for certain things, again, this will be on there. There's just a few more steps. So all you're doing tonight for your homework is just filling in these blanks. It's all set up for you. And you have the steps, on there again, just to remind you how to do them. All right, so this is just the basic template we're going to use. It has step 1, right? Just like we talked about earlier. All right, what are the 2 or 3 unknowns? And then you should say step 2 here, where we wrote earlier, represent one unknown as a single letter, and then represent the other unknown based on the information given, stuff you guys already wrote down on the first note sheet. Last thing, just a reminder, make sure you use the same letter, is all. Yep, just like we did for the first one.
Okay. So just to show you how it would look.
I know the boxes are a little small, guys, but just for the sake of fitting them on there, they had to be a little bit smaller, that's all.
Okay, if you had Paul's age from the previous problem, you'd write it on the first blank, and that would be X. And then who was the other one, Jack? Jack's age. And what was it, 2X minus 1?
Yes.
So this template is just to help you organize your information. And you're going to be doing that for every problem. Except it might not be ages, it could be numbers.
Yep.
Okay, we'll see. So this one says the larger of 2 numbers is twice the smaller.
No. Guys, that was just, that one, the one on the top there, that was just on there, just on there to go over. That's not in your guided notes. That's just on there just to show you guys how the template works. Now, the rest of the examples that we do on the board, they're all on your guided notes. They're all on there, they're all written out, and they have the template set up. All right, so we don't have to waste time with you guys writing them down. They're already on there.
All right. So first thing we got to figure out when we're looking at it is what are the 2 unknowns. Okay, I'll underline them here. Okay.
Numbers.
Yeah. How are they described?
How's it written?
They're described as
Small.
smaller. Yeah.
Yeah.
And larger. Those are the 2 numbers. Those are the 2 things we have to find. Smaller number, larger number.
Yeah, Mr. Hager just put the symbol for it, that's all, so we can fit it in.
Okay, so smaller number, larger number.
Temple was putting smaller number, larger number. That was going to be a little bit of a tight squeeze, but just to fit everything on there, guys, we had to make it a little bit smaller.
Okay, so that's step 1. There's only 2 things in this one, there's not 3. Well, we'll do 1 with 3. Okay, step 2. Pick which one of these gets the single variable. Now, what was the hint I gave you to figure out which one gets the single variable?
At the end of the sentence.
At the end of the sentence. So smaller number gets the single variable. Okay. What should we pick? Sure, you can pick X. Okay, you can pick any variable you want. Pick a variable, though. Don't pick a variable like S, because sometimes S can look like a 5, depending on how you draw it. Same thing with like the letter L. That can look like a 1 if it's lowercase l. Okay, so X is a pretty safe bet. Okay, now step 2, keep reading. Represent the other unknown based on the information given. Make sure you use the same letter. The larger of two numbers is twice the smaller. How did we represent smaller? X. So the larger is twice the smaller. So what would that be? 2x. And for this problem, that's it. You're done. Okay, tomorrow we're going to take it one step further, and I'm going to ask you, what is the smaller number? What is the larger number? You don't have enough information here to do that yet. Okay, so I'll add in a piece of information tomorrow, and then we can do it. Any questions on how we picked the single variable or how we got 2x? Okay, if you have any questions, let us know, because if you can't do this step tomorrow, it's building onto it. So you've got to get this down good. You good with this one?
Now guys, example 2 is to the right of the first one. Right, it's already written on there for you. With Juan's age, it's right to the right, to the right of it.
Okay, so read it over.
Yeah guys, read it over and take a minute and see if you can figure out. Don't worry about how you're gonna represent it, right, with X and all that stuff. All Mr. Hager and I want you to do is just figure out what your two unknowns are. How would you label how those two unknowns, how they're written in the problem?
So just give it a second. So Juan's age is 5 years more than 3 times Sarah's age. Just figure out what the two things in the sentence are. Okay. Anybody think they got the two things? So Yvonne, can you just give me one of them?
I think that Sarah's X.
All right. Well, that's going to be our next step. For now, you're just so Sarah's age. That's one.
Oh, I have a different thing.
So Sarah's age, and can somebody else give me the other thing? Yeah. What is it? Juan's age. Okay, so that's your first step. Figure out the two things you have to represent. Okay, step 2. Figure out which one is going to get the single variable. Ben, which one here is going to get the single variable? And how do you know that?
Because it's like the last one.
Yeah. Sarah's age is the one at the end of the sentence. So it gets the single variable. What would be a good variable? Sure. We'll just use X because that's what we've been using. Okay? And now we've got to read the first part again. Juan's age is 5 years more than 3 times Sarah's age. So if you think you got it?
Yeah.
So what do you think it is?
3x plus 5.
Okay, let's look at it. So it says Juan's age is 5 more than 3 times Sarah's age. Okay? So let's look. Sarah's age was X. We times it by 3. That's good. 3 times Sarah's age. And then more than means we add. So we added 5. So 3x plus 5. Perfect. Any questions on how we got that?
Again, with that one, guys, you could have done, how else could we have represented Juan's age?
J.
That's fine, we could use a different variable, but in terms of actually, like the order of the numbers and the variables. what else could we have done? How else could that have worked out? Anybody know? I could have done 5 plus 3x. Again, with addition, it doesn't matter. I like how, Kitty, I like how you're putting it, the plus part as a second part of the problem, because you gotta do the same thing with subtraction. But you could have done 5 plus 3x. It would have worked both ways, okay?
And as Mr. Roy said, that's only with addition.
Only with addition.
So you ever understand what he just said? Yeah, okay. And that's it. Okay, so for today, we stop at that step.
So like tonight on your homework, guys, again, like I said, you're gonna have the templates on there. All you gotta do is fill them out just like that, and you're done. That's all. Yeah. But like Mr. Hager said, guys, you can say, oh, but tomorrow, when we get into you have to solve for them, that's when it gets a little tricky. So you really want to make sure you get this part down. That's why we're doing so many examples, because we don't want to move on, because then you guys are going to start getting frustrated with this stuff if you don't understand the basic part. It may seem easy now, but we're going to add more tomorrow.
And tomorrow, if you understand how to solve an equation, what we covered back in chapter 3, that's the key. You've got to be able to take, something like this and know how to solve it. Okay, you don't have to do that yet today, but you just have to make sure you remember how to combine like terms, okay, solving an equation. Okay? How do you, that's going to come up tomorrow.
So guys, for this one, it says the price of a book is $3 less than twice the price of a tape. All right? So again, we got to set it up. So, Justin, what's one of my unknowns? What's something I'm trying to solve, set up for?
The price of a tape.
We can do tape, right? Or price of tape, or so we got tape. That's one unknown. Good, Justin. Kayla, what's the other one? Book. Tape and book. Now, Kayla, I know that you know. All right? So I'm going to ask somebody else. Mr. Nermi, which one of those is going to get the single variable? Which one's going to get the single variable? Okay, well, again, Chelsea, what do we say? Which one always gets the single variable? Guys, you can help me out. Oops. Joe? Huh? The tape. Why the tape though, Joe?
Because has a variable.
It does have the variable. What? We could say they both could have a variable, right? I know, but what do we say? What was the rule for that, Kayla?
It's at the end of the sentence.
Again, whatever's mentioned at the end of the sentence always gets the single variable. For 90% of the time. All right, so whatever's mentioned second, or whatever's mentioned last, usually gets the single variable. Right? So the tape, Mr. Hager's going to use T this time. Great. Now we get to the tricky part. Finding what the single variable is, that's the easy part. All I can do is put a letter. Now we get to the part where you get some math that's involved. All right? Marcus, want to give it a try?
Yeah, 2x minus 3.
Go ahead, to what?
2t and with x.
Yeah. The only reason I use T this time is because when we start solving for these, if you use a letter that you can connect with the unknown, then you'll remember, oh yeah, T was tape. If you use X, you might not remember, you could look back, and you should from your work, if X was tape or X was book. T being tape is common sense. You'll remember, T tape. Okay? So, I might start trying that on a couple problems. But that's perfect. Everyone see how Marcus got 2t minus 3? He took twice the price of a tape, and then he took $3 less than that. Perfect.
Remember what we said about less, what do we say about less than, guys, when it's subtraction? What do we say? What was the special rule for that? Anybody remember? What was the special rule for subtraction in a word problem? What did I say? It has to be what? The second part, right? When you're doing subtraction, it has to be the second part. Addition doesn't matter, but subtraction always has to be the second part. Again, that's it. That's all you have to do. All you're doing is setting it up right now. There's no solving, none of that stuff.
You're just setting it up. Now, let's say we knew more information. We might be able to figure out how much the tape costs and how much the book costs. That's going to be tomorrow.
Guys, no, sir.
Okay, so
I'm gonna add one.
this one says the width of a rectangle is 8 centimeters less than twice the length.
Guys, everybody take 20 seconds on your notes and write in your first unknown and your second unknown. Everybody take 20 seconds on your notes, write in your first unknown and your second unknown. What are your two unknowns gonna be? What are the two things you're trying to, like, well, how are they written in the problem?
Okay, so first, anybody see how many are there? Are there 2 or 3? Yeah, in this problem, there's just 2. Can somebody give me one? How about Victoria? Can you give me one of the things you're trying to find?
Okay.
What?
Give me one of the quantities you're trying to represent.
What do you mean, the unknown?
Yeah, one of the
What's-
2
what the
unknowns.
label's gonna be?
With and
With length. Good.
Now, Victoria, can you take it one step further? Which one of those is gonna get the single variable?
the length.
Why?
At the end of
Perfect. Perfect, perfect.
Okay, so this time, she got it perfect. L, I used as the letter this time. That's the single variable. L for length. Tyler?
Flip-flop the length and width.
If you switch them, then it won't come out right. You've got to pick the one at the end of the sentence.
Now, Tyler, you're saying you can do width and length as long as you label, as long as you, when you do your unknowns, as long as you do that correctly. If you had length on the bottom with the L or an X, whatever, and width on the top with something else, that's fine. You can put it in that order if you want. That's completely fine, as long as you're representing it the right way.
Yeah, keep the L with the length, but exactly as Mr. Roy said.
And the
Yeah.
width,
You think you got the width?
yeah.
All right. Let's look at it. So let me read it first. The width is 8 less than twice the length. Okay? What do you think?
8L minus. It's wrong, right?
But I like one thing, you're on track with one thing, right? Minus. We definitely want a minus, right, Victoria? All right, so let's put a minus up there. You're on the right track. You're okay.
You know what I would do? Start at the end and start with this part. Twice the length. What's that? Twice length.
What?
Twice length.
Victoria, I think about it like this. Right now.
2L?
Exactly. Perfect. Because what's your length? Right now your length is L. You don't know, right? That's all you know about length is L.
What is that?
2L. I just don't want my L to look like a 1. So you got to be careful.
And then what's the last part going to be, Victoria?
8.
Perfect.
Yep.
As soon as you see that less here, put that minus sign, you put whatever number it says, right at the end, right at that second part. Then you can fill in the beginning afterwards. You don't want to make that mistake.
And tomorrow, where you might see a problem like this go, the next sentence might be the area of the rectangle is 30. Find the width, find the length. Okay? But today, that's all you got to do. Has everyone got the basics set up? That one seems okay? Okay. Okay, we already mentioned this earlier. Okay, on the sheet Mr. Roy passed out, those words. Of means multiplication. Okay, of is used for multiplication.
Kind of. I'm trying, the other thing I'm having trouble with is.
Okay, so he's passing out this example to you right now.
Yeah, that's fine. It's just
Okay, this will be our last example that we do with 2. The next one we're going to try has 3. Okay, let's read it through and see if we can figure out what's going on. This year, the price of a movie ticket increased by 1/5 of the price last year. Write an expression for the price this year and last year. Okay, first thing we have to do, this one's a little tricky. Okay, what are the two things that we're trying to identify? Anybody give me one of the two? Yep.
The price of the ticket this year.
All right, so we have a price of a ticket this year, which I'm going to put here. All right. Okay. And what's the other thing we're trying to find? We have price of ticket this year. Okay, so and price of ticket last year. Who said that? Yeah, perfect. Good job. Whoops. You know what? Let's put it in. Okay, so we have last year, the price, and we have this year. Okay, which one is going to get the single variable? Okay, this part so far we're still good.
The
Spencer?
price of last year,
Price last year, why?
because it's closest to the end of the sentence.
Right. And what would be a good letter to kind of connect that with last year, so we remember that this? Yeah, let's use L. So now we'll remember L goes with last year.
And guys, Mr. Hager's just showing you guys, he's just using different letters. If you want to use the same letter every time, if you want to use X every time, that's okay.
Yeah, you can use any letter you want, but I think this will help you to remember at the end, when you solve for L, you'll remember L was last year. You won't forget. Okay, now we need price this year. Okay, let's go up and let's read it over again. This year, the price of a ticket increased by 1/5 of the price last year. Okay, so the price of the ticket is increasing. Let's start with that. What operation is that? Addition. Okay, we're adding something to the original price. It's increasing. Okay, my next question is, what is increasing?
The price of the ticket.
The price of the ticket when? Right, last year's price is going up. So you're going to take last year's price and you're going to add something to it. It's going up in cost. Okay? Everybody good so far? So you're taking last year's price and you're increasing it. Now we have to figure out, what are we increasing by? We're increasing by 1/5 of last year's price. That's the increase.
So it would be
1/5 X.
Or 1/5 L. Perfect, exactly. Yep.
And why is it L?
Because you have to have something to increase. You're taking last year's price and increasing it by 1/5 of last year's price. So that's why this one is a little tricky. You're going to have something similar to that. And we'll practice more.
Kind of like we did last week, right? We had to figure out how much, like almost like sales tax, right? We had to figure out how much got added to that price. Something, think of it like that.
Yeah, you gotta have something to start with, or you don't have anything to increase. But luckily, when you see this again, it's going to be set up very similar. Okay? But that's the trickiest two variable type, or two unknown type. Any questions on that? All right, so let's finish up. We'll do one with 3.
Hey guys, I know there's one more on there after this. Again, when we break up, people want me to go over that one on the smart board. All right, as a small group, that's fine. All right, you guys will have that chance.
Okay, so I'm just writing up above. We're going to try an example with 3. That's all. So it says that symbol is triangle. Okay? The first side of a triangle is 3 times as long as the second. The third side is 5 centimeters shorter than the first. And you're like, wait a minute, well, that's a lot of information. Okay, what I want you to do, forget about that second sentence right now. Okay, we're just going to look at the first sentence. Okay? What are the unknowns here? Just let's start with the first sentence, and then we'll see if we get another unknown in the next sentence. Yep.
The first side.
First side, good. Anything else in that first sentence? Second side. First side. Second side. Okay, now let's look at the third sentence.
Yep.
Anything in, or the second sentence? Third side, yep. Good. Okay. Now, go back to that first sentence. Focus on that first. The first side of a triangle is 3 times as long as the second. Based on that sentence, which one gets the single variable?
Wait, on that side?
Yep, just look at that first sentence. Forget about the second one right now.
Then the second?
The first side is 3 times as long as the second. Second, why did you say second? Okay, he's right. Who can tell him why is it second?
You're always wrong.
What's the rule for finding which one gets the single variable?
It's the end of the sentence.
It's at the end of the sentence. Okay, so second side gets the single variable. Now on this one, I'd be careful about using S to represent it because S, that you don't know which side that is. I think for this one I would use X. I would use X. Especially S can look like a 5, and then you're going to start to get confused. Okay? So second side gets the single variable. Okay, let's go back. We're still reading that first sentence. We don't even care about what the second sentence says yet. Okay? In fact, just look at the first sentence. The first side is 3 times as long as the second. How would we write that?
What do we know, what's the second side right now? What do we just say the second side was? X, right? So what's 3 times the second side? 3x, right? All we know about the second side right now is that it's x. That's all we know. So 3 times the second side is 3x. That's all we know.
Okay, so first side is 3 times the second. It's 3x. Now, which one are we missing? We're still missing
Third side.
third side. So now we can go back and actually read that second sentence right here.
But what about this one, wouldn't it? Why wouldn't it be the second sentence ending?
No, for now, I just want you to look at that first sentence. Don't even look at the second one until now. Okay?
Well, yeah, but right now, why wouldn't it be the first side be the X?
Because we've already figured it out from the first sentence, and that part's done.
Okay.
So don't even look at the second sentence till you do the first one. Now we can look at this one. The third side is 5 centimeters shorter than the first. Okay? And the reason we had to figure it out in this order is because now that you know the first, okay? What's the first side? Can someone just tell me what that is?
3X.
It's 3x. Now the third side is 5 shorter than that.
So it would be 3X minus 5?
3x minus 5. Excellent. Okay, I'm always going to give you the problems in the order you need to do it in order to go from one side to the next. You read the first sentence first, then read the second sentence. I'll keep it in that order for you. And for now, that's all you got to do. There's an example with 3. Any questions on that one? Okay, so I'm going to put up your homework. Okay, don't pack up though. I just want you to get your homework first.
I'll give them that template
Yep.
for it too.
So your homework is on page 127, 1 to 19 on.
You got it.